Good morning to everyone. I am happy to give a lecture on Introduction to Probability Theory and Statistics. This is a 12 weeks course, equivalently 12 modules. Let me come to the outline of this course. This has the two parts. First part is probability theory and the second part is statistics. In the first part we have 8 modules, and in the second part statistics we have only 4 modules or 4 topics. This is the introductory level course both on probability theory and statistics, because you can always have a advanced probability theory course. Even one can have a one course on limiting theorems and so on. And similarly, in the statistics also, even though we made it as the 4 modules, each topic can be a separate course. In the advanced statistics courses or statistical inference courses, each one can be a separate course, but we are covering everything in one modules. Therefore, these 4 modules has a very elementary level of statistics along with the probability theory. Already we had a video lectures for first 8 modules on probability theory. Now we are going to discuss the remaining 4 topics on statistics, that is the topic number 9, 10, 11 and 12, equivalently 4 modules. Therefore, it becomes a 12 weeks introduction to probability theory and statistics course. As a reference for this course, I have limited to only 3 important books. The first one is a book by Liliana Arunachalam and myself, Introduction to Probability and Stochastic Processes with Applications. In that book, you can see the material on the first 8 topics or 8 modules for the introduction to probability theory. So, this first book covers the first 8 topics or 8 modules of the our course or this course, introduction to probability theory and statistics. Whereas, for the last 4 modules or part of statistics, the second book, that is Introduction to Statistical Methods, Design of Experiments and Statistical Quality Control by myself and Deviation Das. That book has the first 6 chapters in which these 4 modules materials are available. In addition of these 2 books, we have third book, that is by Rohatgi, that is an introduction to probability and statistics. This book has material on both probability theory and statistics. Many times we use this book in the PG courses, whereas the first book we use it in the UG as well as PG, and the second book also can be used it for UG courses as well as the PG courses. These are all the 3 books which I have made it as a reference, but there are many more good books available for you to understand the concept of probability theory and statistics in an introductory level or elementary level. There are many more books are available. for the introductory level, but there are many more books are available for the advanced level also for each topic. For each topic one can see the lot of advanced level books. But as far as this course is concerned, since this course is the very introductory level, you can go through those 3 books, or you can go through any books which has the similar material in the introductory level. As far as this course is concerned, you should remember it is a very introductory. Therefore, most of the time we explain the concepts, then definition and some more properties over the concepts and the definitions. Then we illustrate 1 or 2 examples to understand that concept. We will not go deep into everything. It is not possible to cover in these 4 modules. So, the way I am going to explain the statistics part, these 4 modules are also in the elementary level, similar to the elementary or introductory level of probability theory, which we already discussed in the earlier 8 modules. Of course, there is a lot of connection between probability theory and statistics. Therefore, this course is going to be very good for the students who are interested to do research in data science or any predictive analysis, or if the students or the people are interested to do any data oriented research. This course is going to be in the elementary level. Based on your interest, always you can move to that particular topic and you can study in detail. But since it is elementary level, we discuss in a very easy way of examples and some definition with the concepts, that is all. With this brief introduction about the statistics part, now I will move into the topic number 9, that is the descriptive statistics and sampling distributions. Now we start the topic number 9 in this introduction to probability theory and statistics course, that is descriptive statistics and statistical distributions. It is very difficult to explain the descriptive statistics along with the statistical distribution in one module. One module means we make it of 3 lectures. So, I am planning to give one lecture on descriptive statistics and 2 lectures on statistical distributions. Even both 1 lecture and 2 lectures on descriptive statistics is not enough, but still we will try to cover because of the introductory nature of this statistics part. So, let me first explain the first part of topic number 9, that is module 9, that is a descriptive statistics and statistical distribution, that is descriptive statistics. Before you go to descriptive statistics, we should know what is the meaning of statistics. The way we understood the probability, we should have an idea about what is statistics. Statistics is the science of data. It is a science of data. It has many forms: statistical methods, statistical inference, statistical analysis. So, any things which you do it with the statistics, that means you are working with the data. Suppose we do statistical inference, that means you are trying to get some information from the data, that is called a statistical inference. Suppose I say that is a statistical analysis, that means you analyze different measures, different attributes, different quantities with the help of data. If I say statistical methods, what are all the methods in which one can analyze the data based on the questions or based on the issues with you that can be studied by different methods using the data, that is statistical methods. As far as this course is concerned, we will be mainly on statistical methods. That means, suppose you have a problem, you want to solve the problem with the given data, which method to apply, which is the good one to apply and get the final results or final conclusion. So, this introductory statistics course is mostly on, as far as this course is on statistical methods, not on statistical inference, not on very in detailed study of any statistical concepts. We will be touching all the concepts in a very easy way with the examples, with the real world problems also. Fine. Therefore, the challenge is how you extract the information from the data. That means, first you should know how to collect the data, and one should know how to classify the data, and then you should be able to analyze. Some methods you have to apply to analyze. Then you come to the interpretation, how you conclude from the analysis what you have done. And it has many different approaches and so on. There are several techniques. By the way, you should not feel this statistics is completely different than your day to day life. Even we are doing day to day the statistics in a typical day to day life. For example, you want to buy the new dress. It is not just you pick some dress. First you open your drawer, what are all the dresses are available with you. That is a collection of data. Then you classify the dresses. Okay, we have this type of dress this many, this type of dress this many summer dress, this many winter dress, or this many going out dresses, or this many casual wear, this many office dress. You classify. Then you analyze whether we want to go for buying this type of dress or whether we want to go for. After classifying, you feel like, okay, we have very less outgoing dresses, going out dress, or you feel like we do not have much dress for winter. That is analyze. Then you interpret, okay, now I will go for buying the dress which is I want it. I am just giving one example. Or you think of some company. In the company they want to recruit some more people. So, the objective is they want to maximize their profit. Then they cannot just bring somebody to become an employee of that company. They have to first analyze who are all the employees with them, how many employees are there, in which category, what are all their ability to do the work, and how much they are worthy. You do complete analysis, then you come to the conclusion. Initially I thought of recruiting so and so employee for so and so division. After doing this exercise, I realize no, we do not need it now, we can postpone. Or initially I would have thought I should go for only one more employee, but after analyzing I figure it out, I may need more than one employee, 2 or 3 employees in this category, or 2 or 3 employees in other category, and so on. This is statistics. I will go to the third example. When in the house, when people buying some particular items to prepare the food or something, they will not just go to that shop and buy something, they would have completely analyzed whether those many items we have already and what particular item is missing or that is over the period of time, when to order, how much to order, all the statistics they do it, but they may not know the different jargons which we are using. So, the data analysis with the statistics, it has so many jargons, but if you really see it, all the jargons are words which is related to this topic, but actually you are doing in the day to day life. If you keep it in that way, then it is easy to understand the topic and understand and follow it, and you can come up with the new ideas. So, even though it is an introductory level this course, by visualizing the different examples for each concept, then you will know why this particular method is used, why not something else, what is the condition is satisfied, or what are all the limitations with this. Therefore, we have landed up applying this method to conclude the so on so results. So, everything is well connected as long as you are able to understand the concepts in a day to day life. That is what I am asking you to connect every concept with the day to day life examples, then you will not forget. That will improve your idea of understanding the concepts and implementation and make it better. Fine. Yes, as I said, in this course we are going more on statistical methods. Even though this course is of the introductory nature. So, whatever we are doing currently, it may have many more features in the statistical methods, but we cannot miss or the contribution by Professor C.R. Rao. He is the person who contributed lot for the statistics, and many of the concepts he has made it with his contribution, and later we are going to see his name in some of the concepts also as the with his name. So, that is the first one I want to emphasize in this course, and of course, in this course we are going to mainly concentrate on how one can do the descriptive statistics, and suppose you have a data, how one can fit the data with the closest better distribution or goodness of it, or how one can identify the distribution of the data which you have observed. In other words, what is the statistical distributions or sampling distributions, this we are going to study, and then later we are going to come up with different ways of finding the values using the data. So, once you use the data to find the values, we use the word estimation, not obtaining the values. So, we are going to estimate many parameters, and those parameters are nothing but the parameters of the population distributions. So, we are going to estimate different parameters either in the form of a point estimator or in the form of an interval estimator. We are going to estimate the parameters, that is the separate module. And then we are going to discuss about how one can conclude or how one can validate the statement which you made it with the help of parameters or related to the data. Whatever the statement which we have want to validate, that is possible with the given data. So, those tasks we are going to do it under the title called testing of hypothesis. And finally, we are going to make a one separate module for analyzing correlation and regression. So, these 4 modules are divided, this whole statistics is divided into 4 modules, and the first module is descriptive statistics and sampling distribution. It is more of data as well as what is the distribution for the different sampling. And the next module we are going to discuss about the estimation, and the third module we are going to discuss about the testing of hypothesis, and the fourth module, that is last module, we are going to discuss analysis of correlation and regression. One should remember these are all not only the topic in the statistics, but these are all the 4 topics or 5 topics we combined descriptive statistics and statistical distribution in one chapter, one module. Therefore, these 5 topics are going to be the main topics whenever you want to study the statistics. Therefore, we kept these 4 topics, that is descriptive statistics and sampling distribution, second is estimation, and the third is testing of hypothesis, and the fourth is analysis of regression and correlation, and this put together that will form some statistical methods. So, we are not going to discuss the theory behind these topics. We are going to go in a very elementary way with the concept, definition with the real world examples. Fine. Before moving into in detailed, one should know the difference between or what is the connection between probability and statistics. It is well connected, probability and statistics. More you understand the probability theory and statistics, then you can able to feel it what is the difference between probability, statistics, and of course, there is another topic called stochastic processes. All 3 are well connected: probability, statistics and stochastic processes. Let me start with statistics. Even though I have made a slide, I am not going to read out this slide as it is. The starting point is statistics. Whenever you observe the data, you want to analyze the data, that becomes statistics. When you analyze the data, you feel like some concept is coming again and again, or you may feel this particular data always fall into this category or fall into some particular concept. So, that concept can be nicely well defined, that is probability theory. For example, you see the number of people who got the marks in a particular course. If you draw the histogram, that is a descriptive statistics, you draw the histogram, number of students versus marks of the students. Suppose out of 100 marks exam, how many students who got between 0 to 5 marks, how many students who got 5 marks to 10 marks, how many students between 5 to 15 marks, like that you partition. You make a table. Suppose you have a class of 70 students and you look for how many students who got the marks between different interval, 0 to 5, 5 to 10, 10 to 15 and so on, 95 to 100. You make a histogram. X axis is the interval of the marks, y axis is number of students who got the marks in that interval. This is one scenario. Like that you can think of many more examples. You can draw the histogram. Many of the histogram, if you join the midpoint of those histograms, you will have a smooth curve. The way I said one example, like that if you make a x axis different information, y axis some other counting, you will have a different graphs. But if you see most of the graphs that will fall into one category, you can guess also, somebody who is listening, you can guess the midpoint of joining the histogram diagram, you will have a nice graph, some smooth curve. It increases, it reaches some value, then it decreases. If you understand this graph can be well studied in a mathematical way with the proper function, all the concepts and everything. You can come to the conclusion this data falls into normal distribution. That means the normal distribution can be well studied in a probability theory, and this particular data fall into normal distribution. Like that, whatever the different data you analyze, you may land up with some concepts which is underlying, and that can be well defined in a probability. Therefore, the probability is the abstract way of describing the real scenario, whereas the outcome of some of the real scenarios, that is can be studied via statistics. So, it is a back and forth. The probability needs statistics information to develop better concepts, and from the better concepts whatever you get the results, you can always make it a better conclusion. So, the data, analysis, theory, these form a triangle. Data, analysis, theory forms a triangle. So, you can keep on improving. The theory can be improved. You can validate that theory by getting another set of data, by doing the analysis, then the theory can be developed. So, the triangle form the data, analysis and the theory. So, this can be keep on improving till you succeed, till you come to the conclusion, okay, now you are satisfied. In the predictive analysis or in the forecasting analysis, this is the work is done. For example, they want to do the weather prediction. They have a past data, what was the weather condition for last 15 days or last 1 month, that is a data part. Then you analyze, then you come to the conclusion, tomorrow this is going to be the so and so weather, sunny or rainy or whatever it is. Then that can be validated by getting some more data and analyze, then your conclusion can be better and better. So, the abstract part of mathematical concepts, that comes under probability. The data oriented information, everything comes under statistics. And when you develop better and better model and so on, we call it as a probabilistic model. If you want the estimating some parameters of the probabilistic model, you use the statistics. So, using the statistics you can do any data related work that can be feeded into the model, and you can go for predicting or forecasting or whatever the analysis you do, that you do it with the probabilistic model using a statistical concepts or statistical methods. So, there is a very clear cut difference between probability and statistics. What you do accordingly, it could be dominated by probability or it could be dominated by statistics. I cannot use the word it is only probability or only statistics. There is a inbuilt connection between probability and statistics, you cannot remove it, but based on your problem one topic will be dominated comparing with the other topic. Even though I said there is a word called the stochastic process, I am not going to discuss in this course. Those who are interested, you can read it somewhere else. What is the connection between probability and stochastic processes also. So, as far as this course is concerned, our problems of interest is data representation, fitting the distribution to the data, estimation of parameters, testing of hypothesis, correlation and regression. These are all the only 5 topics of interest. Therefore, the first 2 topics going to be the topic number 9, and estimation becomes topic 10, testing of hypothesis or hypothesis testing becomes a topic 11, and analysis of correlation and regression becomes a topic 12 or module 12. These are all the importance for our course, and we are not bothering about all other concepts because of the course is introduction to statistics also. Yes, descriptive statistics. The way the word says descriptive statistics, how you describe the data. There is no unique way. Based on the data, how you represent or how you characterize the data, that is called the descriptive statistics. There are variety of applications playing with the data, but we can make it into the some way of nice characterization. Whatever the example you say, automatically it boils down to in this characterization or whatever the way we classify nicely, that we are going to do it in the descriptive statistics. Yes, that is started with these 3 words: data, information and description. That means you have a raw data. From the raw data you want to infer some information from the raw data. Then what are all the information is interest to you, that is the next step. Then according to the information you want it from the data, you describe. So, therefore, the description comes third point. For example, I want to know how many students are doing well in my course. That is the information I want it. That means I have to start collecting the data, keeping that information in the mind. Then I have to describe the things properly so that I can do the analysis. Since my interest is to know how many students are doing well in my course, I will start collecting the marks of their marks, whatever the term 1, term 2 or final or whatever the different exams, quizzes, assignments, whatever the form, I will collecting all the data, keeping I want to know the best students in my course. Then I will start making that information. My interest is marks. So, then I will collect the marks of the students. Then I will tabulate it in a nice form, because my objective is who are all the best students. That means, I want to make a classification of suppose it is 100 percentage marks, then I should be able to classify nicely, so that I can take who are all the students got the good marks in the course. That is done. So, this is a very easiest example. Being a teacher, I can able to say it immediately, but like that there are many more examples. Accordingly, the data varies, the information which you want, that also varies, and the description also accordingly it varies. So, in general, how it is going to be classified, that we are going to discuss. Yeah, I am not going to talk about what is data and so on, that you can able to come to the conclusion easily. It is observed information or raw data, we call it as a raw data. So, for instance, we have given some examples also like that. You may have immediately in your mind that also can be considered as a data. Fine. Yes, this is a very important word in this course. One is called a sample and another one is called population. The possible values of data which you are going to get it from that whole set, that we call it as a population. And whatever the data which you collected from that bigger set, that is going to be called it as a sample. For example, I want to know some particular information from the students. There is a class of 70 students. I asked one questions to them, or I want to pick some few students as a for some other task. Out of these 70 students, I want to pick some students for some job I have to assign to them. For that, I want to choose some 5 students out of that 70 students in a classroom. So, the 70 students becomes population, and I am interested to pick only 5 students for some particular task. I can choose 5 students among these 70. So, these 5 students becomes the samples. And how I am going to do the sample, that is a different theory, that is a sampling theory, that is a different story. So, the samples is basically the data which I have taken from the bigger collection, that is samples, whereas that bigger collection, the whole set, that is going to be called it as a populations. The people who have studied already probability theory, one can relate the jargons which you discuss in the probability theory course and the samples and the population. You can make a one-to-one correspondence with the samples and populations with the jargons which you learned it in the probability theory course. For example, yes. Yeah, what is the question? Oh, you are not able to see the screen. Ah, okay. So, that they will correct it, but still, okay. Maybe I have to mouse it. So, you can cut it later. Yeah. So, there is a one-to-one correspondence between samples and populations with the jargons which you have studied in probability theory or probability course. Those who have a idea, the way I gave example, you can make out that is going to be call it as the samples. There also we are using the word sample, each possible we call it as outcome. So, the sample here that is same as outcome, and the population is nothing but the whole collection of all possible outcomes that will form a population. And the difference between the probability concepts and the statistics concept is there you will say that one out of all the possible outcomes can happen. Therefore, each one is going to be a one possible outcome, but here you have all the population, all the possibilities are in front of you, that becomes a population, and you choose few elements from the population, that becomes a samples. And there any one of the possible outcomes can happen. Therefore, you have omega which has the all possible outcomes, and you say that one possible outcome is going to be the one sample, or here the sample means one out of the whole population, that becomes a sample. And usually we take a finite number of samples to do any statistical analysis. So, always we use the word sample of size n. That means the small n we use it, that is for how many samples which you have taken from the population, that we call it as a sample size. And the population size, most of the time we use the letter capital N, and the sample size we call it as a small n. There is a possibility the population size could be infinity also. It is not the example which I have said 5 students are selected out of 70 students, therefore, there the population size is finite, but there are certain cases the population size can be infinite, but most of the time your sample size is always finite. Most of the time your statistical analysis we do the collection of samples always finite, which is a small n, whereas the population size could be finite or infinite. Yes, now I am coming back to the concept of data. So, data can be classified into categorical or numerical. Once it is a numerical data, then it could be discrete or continuous. There is no confusion between discrete and continuous. Whenever the numbers are going to be finite, discretized, then we say it is a discrete data. Suppose you have a countably infinite numbers, when you have uncountably many values, then we say it is a continuous, whereas countably infinite and discrete values, that you keep it as a discrete data. Once you have uncountably many values, I am making a mistake again. So we can cut it later. So, you can classify the data into two forms. One is a categorical data or numerical data. In the numerical data, the data is always in the numbers. That means it could be a real values, or it could be just integers or some discrete quantity, discrete values 1, 2, 3, 4, 5 and so on. So, again you can classify the numericals into two forms. In the sense, suppose you have a finite number of discrete values, or you have a countably infinite discrete values, you can come to the discrete classification. Otherwise, if you have a real numbers, it is a real numbers, many values. Suppose you think of a real value between the interval 0 to 1, then it comes under the classification of continuous. It is sometimes uncountable also. Uncountably many values comes under the continuous case, whereas finite or countably infinite comes under discrete classification. Fine. Now, I am coming to the non-numerical. Basically, non-numerical is going to be called it as a categorical. In the categorical, you can always classify into the nominal or ordinal. Yeah, let me check whether that line is there or not. Yeah, I have given the example immediately what is nominal and what is ordinals. And I did not give the example for numerical, both discrete type or the continuous type, whereas I have given the example for categorical, whether it is a nominal or ordinal. So, this is the classification of the data. So, the way I explained the data, information and the statistics, that can be well defined in the nice descriptive way. The important thing which we have not discussed till now, that is the word statistics. Data we have discussed, information also we have discussed. Now, we are coming into the important word next to samples, populations. The third important word is statistics. The statistics is basically a function of random samples. Even though I am going to give a mathematical definition later, it is basically a function of random samples. For example, average or mean or standard deviation. So, these are all the measures you can able to calculate with the help of nice function in the form of random samples. So, I have explained the word sample, I did not explain the word random sample. So, basically the statistics is a function, it is a function of a random sample. So, once I explain what is random sample, then you will come to know the word statistics. So, basically the statistics is the function which is used to measure different concepts related to the data. It is just some function that is called a statistics. How we are going to create the function, that after I explain the random sample and so on, then you will come to know how, what type of function or what type of mathematical function is going to be called it as a statistics. There are certain function you cannot conclude it is a statistics because it is not satisfying some condition. So, as long as you create a mathematical function with some conditions, then that function going to be called it as a statistics. Fine. Now, we are going to describe what are all the ways you can describe or graphical representation of data. The easiest form is the frequency table and the second one is the contingency table. So, these are all the two ways you can graphically illustrate the data. The way I said the marks of the students can be classified into many intervals, then you make a x versus y axis graph with the how many students who got the marks between that particular interval. So, like that there are many different way of graphical representation of data. So, the important thing is the frequency table and contingency table. Let me explain some of the things through proper example. 1 minute. Yes, this is the one particular example which we are going to discuss in this course. We are collecting some data of 20 persons information to do the statistical analysis of different things. For that we have collected 20 samples, the sample size is 20, and we have noted down their heights, then the marital status, and then their weights, and what is the meaning of EL? What is the meaning of EL? Yes. So, we have taken their education level. So, in this example we have carried out the population size is 1500 and the sample size is 20, and the information which we have collected accordingly the tables is created. Fine. So, this is the observed data for the example which I want to explain, and the same example is going to be illustrated for the graphical representation of the data also. So, this we have explained already, this also we have explained. Yes. So, yes. So, this is the contingency table which we can able to create for the same example. In gender based, what is the male or female, whether they have a disease, and what is the information that can be made it in the contingency form. And you can go for the frequency also. Yes. So, this is the frequency in which you classify the whole 20 samples into the 5 classes, and in the interval in which how many frequency happening, then you can able to find out the relative frequency, and you can do the computation based on the frequency. And another one is the bar chart. Yes. So, one can represent the different education level and how many officers are having this different education level, then that becomes the bar chart. And it is possible to make a pie chart also with respect to the weights. So, how many officers are having the weight between 83 to 86, what percentage, and similarly how many officers are having weight between 87 to 90, like that you can able to make a pie chart. Then it is possible to make a frequency histogram also and the dot plot. So, this is going to be call it as a frequency histogram. The same thing what I explained with the 70 students, the marks obtained in the different interval, that is possible with the different interval and the frequency of the class. So, the same thing it is done for this particular example. And the dot plot graph means you just make a dot, how many are of the different classes, and put the point. And similarly, you can make a frequency graph. So, all are the graphical representation of the data. Yes. So, we call this is going to be this graph we call it as a normal histogram. So, because it follows a sort of normal distribution. sort of normal distribution, whereas if you see these two graphs, it is a sort of skewed, therefore, it is called a skewed histogram. For the same example, you can go for the box plot. So, you can understand what is the meaning of box plot, and if you have a given data, how one can plot. Nowadays, there are many statistical softwares are available. If you feed the data, then what is the type of graphical representation you want, once you enter those things, it is easy to get it. So, you do not need to put your effort by doing by hand. You can do it by hand also, but if it is a sample size is small, it is easy to do it by hand. But once you have a huge data, the sample itself huge. The example I said 70 students as the population and 5 students as the sample size, but in a realistic scenario, sometimes the sample becomes a huge and the population is going to be very huge. So, it is not easy to make a graphical representation by hand. So, there are nice software packages are available. You feed the data with which attributes you want to make a graph, and accordingly you can get the frequency histogram or pie chart or bar plot. All possibilities are there with respect to the given description and the data. Yes, the other important thing is a cumulative frequency graph. This is also very important graph. This will give an idea when it is touches some particular range. Yes, then another point is the quartile. The quartile also will give what type of quartile you make it and where it is crosses this quartile. When we submit the research papers, we look for the research paper where we are going to submit the journals, it should be Q1. That means it should be top 25 percentage. That means it is a first top 25 percentage we can fix it, or Q2 means it is between top 25 percentage to top 50 percentage. Q3 means third quarter, and Q4 means bottom 25 percentage. So, quartile is very much important when you want to classify the things into the different classes. Similarly, the cumulative frequency, this is more than O gave for the variable 4 which I have described. So, we are taking the same example, and for the same data set we are describing the data in the different graphical representation. Finally, we are going to do the complete analysis also. So, some of the descriptive measures which let me list out, because anyway we are going to discuss in detail later. Yeah, this is also very important result. It is called a scatter diagram. This is also graphical representation of x versus y. So, here weight versus the height, we are making a scatter diagram. So, this type of diagrams you would have seen it in many different applications. Yeah, the first important descriptive measure is the mean. You add all the values divided by the total number of sample size, that is going to be the mean. So, this is a very important descriptive measure. And the next descriptive important measure, that is median, that you would have seen it in the real ways where the median is placed. And we have both the discrete and continuous, then quartile, percentile and quartile, that also one can study easily by different places. And then yes, we divide the data into 4 equal parts, that is quartiles and deciles and percentiles. So, these are all the things we do it based on the problem. Yeah, for the same officer example we have done the same exercise. Now I am coming into the third measure. Mean we discussed, median, the third one is mode. So here we have given the definition of mode, the mode of a sample x1, x2, xn in its most frequent value, namely modal value, that is defined as L plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 times h, where L, H, f0, f1, f2 are written in this slide. Then the another measure is geometric mean. If you have a sample of n data, one can able to find out the geometric mean. Yes. Then next to the mean, the other important thing is sample variance. You have a sample of size n, from there you are trying to compute what is the sample variance, how much it is deviated from the mean, and the denominator is 1 by n minus 1, not 1 by n. That is a very important thing. This n minus 1 is called the degrees of freedom. That means a number of independent information that comes into the picture, therefore, it is 1 divided by n minus 1, not n, because that as a easy way you can explain. Suppose you have a n values and I supplied the mean also. Do you need the nth value? Yes. So, if I say n values and the mean value, the nth value does not matter. That means that is a redundant information. So, the n minus 1 informations are independent information along with the mean when I supply. Therefore, when you compute the sample variance, you will supply the mean. Therefore, mean and n minus 1 independent data is enough to compute the sample variance. Therefore, n minus 1 are independent informations here. So, that is going to play a degrees of freedom. Fine. So, one can compute the sample variance. Then one can easily compute the square root of positive square root of that, that is the standard deviation. So, now one can make a conclusion for one more measure, that is a coefficient of variation also one can compute with the standard deviation divided by the mean. This also play an important role for some real world problems, not all. Coefficient of variation also important other than mean and variance. Yeah, so we have done the same example how one can do the things. Yeah, the skewness you can able to find out with the third order moment, you can easily able to get with this calculation you can get the skewness. So, if it is symmetry, then you will have the skewness is going to be 0. So, obviously for a normal distribution the skewness is going to be 0. So, if it is positive or negative, accordingly you say it is a positive skewed or negative skewed. And the next measure is a kurtosis. So, this I am giving a visual, it is a symmetric, the middle one, and one is a positive skewed and the other one is negative skewed. Yes. So, preparing the report, that is going to be the end of the descriptive statistics. Yes. Okay. So, one more measure which I want to emphasize, that is kurtosis. So, the sequence is mean, variance, then skewness, then kurtosis. In between you have a median, mode and coefficient of variations, but main things are mean, variance and suppose you want the higher order moment, because the mean is the first order moment and the variance is related to the second order moment. and the skewness and kurtosis will play the higher order moments. Yeah, so this involves the fourth order moment for the kurtosis. Once you have, then yeah, the kurtosis also one can make a graphical representation. You see that. So, there is a different names according to the nature of the kurtosis. Yes. So, this is also very important graph. This also give an idea where the mean lies for a normal distribution, and what is the coefficient of variation, and what is the standard deviation, and what is the variance. So, if the data falls into normal distribution, you can feel this. It is not anything will fall into this. If the data falls into the normal distribution, then you can feel this type of values. Mean will be in the middle, mean, median, mode all are going to be same, and all the other measures will come into that much bigger and bigger. I want to show the one yes. So, this is a summary report. So, for this particular example I was going very fast, but you can put the pause and you can go through those examples carefully, and this is a summary report for the same example, different measures how one can compute the descriptive measures one can compute, and from this you can get many more information as the summary report. So, with this let me complete the descriptive statistics of topic number 9, that is part 1, and the part 2 I will start explaining the sampling distributions in the same mode. With this let me complete. Thank you.